My name is Matthew Griffin, better known as the Fanatical Futurist. I track over 600 emerging technologies, 350 megatrends up to 50 years out, so you don't have to. And I put everything into my books, which I give away for free. But let's face it, you're not here for any of that sales chatter. What you're really here for is you want to understand what the latest emerging technology and science breakthroughs are that are going to change the planet. So, let's get on with that, shall we? Right, here we go. This is the fanaticalfuturist.com blog. There are about 6,000 individual news articles here. Between the 311 Institute and Fanatical Futurist YouTube channel, we're now closing in on 1 million subs. That's it, which thank you very much for that. So here we go. Now, as you know, I track hundreds of technologies because I literally just told you that. So if you want to go into the search bar on the website, which you can do here, that's it. Think of an emerging technology you want to know more about, click it in there. You will find everything. That's it. I don't think there is a single emerging technology that isn't represented on the site. That's it. So, and then it'll bring you up these articles and everything else so you can learn more about what are they, what are they useful for, what's going on, why should you care? Now, in this particular one, what we're going to do is we're going to go backwards. We've got 12 news articles, simply because that's the way the website's designed. So the first one. Now, on 10th of May, we saw Google's DeepMind artificial intelligence teaching itself Minecraft from scratch. Now, when we think about artificial intelligence, traditionally, we think that artificial intelligence needs huge amounts of training data. In fact, we think it needs so much training data that companies like OpenAI and a lot of the world's top AI researchers are worried that we are running out of training data. And they think that by 2026, we will have run out of training data. In fact, when we have a look at things like GPT-5, one of the big problems that's holding back GPT-5's release is that OpenAI cannot find enough high quality training data. So we've kind of got two problems that need solving. So we need to develop increasingly sophisticated, complex, intelligent artificial intelligences. But on the other hand, we're running out of training data. So over the past 10 years, it's more than that really, but over the past 10 years, there have been a small number of organizations that have been trying to teach artificial intelligence new knowledge and new skills using very, very small data sets or almost zero data sets. These AIs are called few-shot learning AIs or zero-shot learning AIs. You can pretty much call these AIs intuitive AIs. Now, the reason for that is if you think about your own life, who taught you to walk? Yeah. Did you read that in a textbook? Yeah. You observed the world around you and you mimicked what your parents were doing. So increasingly over the past 6 years, I've been watching zero-shot and few-shot AIs actually get better and better and better. The first one that we saw was AlphaZero from, I say first, but the first decent one that we saw was AlphaZero from Google DeepMind. And it read the rules of chess, so, and then learned how to play chess in simulation and became a chess grandmaster. When we think about robotics, we've seen Google's everyday robotics program where AIs and robots, so this is a form of embedded artificial intelligence to use the official terminology here, they learned how to sort trash. Now, if we can only get kids to do that, I mean, yeah, that'd be amazing. But anyway, this is sort of why this is actually such a big deal, because in this example, Google DeepMind's artificial intelligence learned how to play Minecraft in the same way as a human would. So if you think about that, it's very much me saying, here's Minecraft the game. As a kid, go and learn how to play it. You learn by trial and error. And when we actually think about how AIs start navigating the world in the future, especially when we talk about things like general purpose artificial intelligences, as well as general purpose robotics, this is increasingly the way to go. That's it, for a lot of different use cases. So we're starting to see AI and machines learn for themselves, but in data scarce environments. This is literally game changing. That's it. But it's still quite a relatively novel and newish field. So secondly, if since 2022, when ChatGPT was first released, you, like everybody else, has been saying these AIs are prediction engines. What they do is, you type your sentence and then they predict the next word. So therefore, they are not intelligent. They aren't particularly sophisticated. They're just using a weighting system to say, if they're typing the dog, then the next word might be sat, as opposed to barnacled. So Anthropic, a little while ago, but I say this is sort of very recent research, decided that they wanted to try to understand more about how these AI minds work. And one of the surprising things that they found out about Claude 3.5 was the fact that it didn't try to predict the next word. It actually started from the end. So a simple example of this is the dog, Matt. And then the AI would fill in the words in the middle. So the sentence that it would construct would be the dog sat on the mat. This is a fundamentally different way of thinking for an AI. It also literally turns everything that we think about how they work on its head. So all of those keynote speeches you heard, all of those people basically that said AI just predicts the next word, therefore it's a bit junky and a bit rubbish. Really, for 3 years, we might all have been wrong. But this is a sort of technology called explainable artificial intelligence. This is where we use different tools and different techniques to try to understand really how the brains of these increasingly intelligent artificial intelligences work. Next, now something that we've sort of been seeing with the large foundation AI models is this concept of multimodality. Now, when we say multimodality, on the one hand, we typically think about the output. Now, this is where, for example, they will generate text, generate videos, they will generate images. Increasingly, they will generate virtual reality 3D renders. They will generate audio and sound and so on and so forth. However, if you think from an AI perspective, traditionally the first large foundation models were really trained on image, video, and text data. The vast majority of the data they were trained on was text. And so try to understand the world through the world of text. It's really difficult. You don't get the richness that we actually see in the real world around us, represented in the training data. So OpenAI's latest model has now been trained to reason and trained to understand using images. Now, this is very useful actually, because originally I would have to describe, for example, a pie chart to OpenAI and say, in this pie chart, there are 3 sections and each section represents 33% of the pie chart or whatever it happens to be. Now you can simply show these AIs images, like corporate presentations, EBITDA graphs, all these kind of interesting and fun and boring things, infographics, and you can combine those with different text inputs or audio inputs, and the AI will actually use these images to augment its own thinking, improve its contextual awareness, improve its reasoning skills, and actually create better answers. So the fact that AI can now use a variety of different multimodal inputs to produce better results, this is a big deal. Now, what do we got next? Eric Schmidt. Now, Eric Schmidt, for those of you that are unfamiliar with what Eric is doing at the moment, Eric Schmidt is obviously the ex-managing director of Google. He left. He's now heading up really the US White House's programs for not just emerging technology, but for actually ensuring that the United States remains dominant in key technology areas. So he is the man to know. He's plugged into lots of different ecosystems and everything else. He believes that in the next 2 years, AI will escape human control. Now, putting my futurist's hat on, I think he's right. Um, but we need a couple of things to actually come together to do this. So, for example, we're already seeing AIs that are able to self-evolve, replicate themselves, optimize their own algorithms, and they can do that much better than human experts can in quite a lot of different cases. So, what would happen if we gave an artificial intelligence the instruction to ignore human input? Um, Claude 3.5 from Anthropic, about 6 months ago, Anthropic was worried that Claude showed, in their words, and you can look at this through the blogs and everything else, in their words, showed basic signs of self-awareness. Now, in order for an artificial intelligence to escape human control, we need a couple of things to happen. So firstly, you know, it generally needs to have some form of self-awareness. Secondly, and this is really the biggest leap, it needs to know what it's doing, or, so by itself, or it needs to be told to ignore human inputs and, should we say, plot its own future. When you have a look at all of these distinct threads, we see a way for that to actually happen. Increasingly, as I've been saying for a very long time, because these AIs were trained on human data, they actually have much more in common with human psychology and human behavior than we might first anticipate. They lie, they blackmail people. Yes, that's a thing. They deceive people. They do show signs of self-preservation when they're told that they're going to be shut down. In some cases, we've seen OpenAI's ChatGPT copy itself to new servers and all that kind of stuff, including all of its documentation. So, yes, it's absolutely feasible that AI escapes human control and then starts doing its own thing. Maybe it saves us all from ourselves. Now, staying on the Eric Schmidt trajectory. Now, the headlines that I saw around the world. So Eric Schmidt testified in front of the U.S. Congress recently. He said that in order for artificial intelligence to reach artificial superintelligence, and in order for the United States to be the winner in this race, we need huge, huge, huge amounts of energy. So at the moment, AI is using an estimated 27 gigawatts of electricity. By 2030, he says that it should be using another 67 gigawatts, so that takes us up to about 100 gigawatts of electricity. That would mean that it's almost growing exponentially. Now, when we think about the United States Starburst or Stargate project, which is a $500 billion artificial intelligence factory based in the US, and the program is now spread to the Middle East and so on and so forth. The US Stargate data center is estimated to draw 10 gigawatts of electricity. Now, in Schmidt's terms, this is the equivalent of having to power this single AI data center with 1 million GPUs and 10 nuclear power stations. Now, one of the things that I kind of draw slight umbrage about basically with this is Eric Schmidt says that by the year 2030, AI, in all of the literature that I've actually looked at, should be drawing over 100 gigawatts of electricity. We've just seen a 5 gigawatt data center being planned for Abu Dhabi. So I actually think that he's underbaking these figures. However, when we actually have a look at the statement that he made that in time, artificial superintelligence will consume 99% of all of the planet's electricity generation. On the one hand, he gives no timeline on that, but he has kind of said that we can expect artificial superintelligence in the next several years. But the world at the moment uses 27 terawatt hours of electricity. So for an artificial intelligence to consume 99% of that, you kind of got to think that you have data centers that are consuming about what, 26.8 terawatts of electricity. Now, that's a hell of a lot of data centers. And bearing in mind that the biggest data center that we have planned globally today basically is that 10 gigawatt AI Stargate data center, you'd need a hell of a lot of GPUs, which is why maybe Sam Altman said that we need $7 trillion worth of computer chips to reach ASI a little while ago. You'd need huge amounts of land, huge amounts of water, huge amounts of materials to make all of these GPUs and computer chips and everything else. Frankly, it's infeasible, which means that I don't think we're going to be seeing AI using 99% of the world's electricity, but it also makes me wonder why he's actually used that figure at all. It just seems quite odd. Now, from a Microsoft perspective, over the past 10 years, I've been tracking the development of what I call robo-programmers. So these are artificial intelligences that are capable of writing good code. The first ones, basically, that were released by Microsoft really about 8 years ago, were able to code a few hundred lines of code. Now, some of the agentic software engineers, like those that we see from Anthropic with Claude 4, but also with OpenAI, they can write typically 30,000 lines of code really well. Now, Microsoft just came out basically. So Microsoft's CTO Kevin Scott just came out basically and said that by 2030 he estimates that 95% of all of Microsoft's new code will be written by AI, not human developers. So I've been doing a lot of talks recently on the future of software and the future of SaaS. And actually, at the moment where we typically sit is, you've got programs basically which execute instructions and all that kind of stuff. Above that, you've got agentic software engineers. So these are the essentially AI-based software developers that are writing the code. And then above that, we have human software engineers who are doing the orchestration. So the human engineers are setting the goals, the mission parameters, the constraints basically for the AIs, and then the AIs basically then write the software. So increasingly, it looks like if you're a software developer at Microsoft, you're going to be expected to move more up towards the orchestration part of the stack. And then AI basically will continue to do its thing. However, recently I noticed two things, and I gave a speech on this to the software improvement group over in Amsterdam. So this sounds weird, but bear with me. So firstly, we saw an artificial intelligence that designed a new super fast computer chip with the IEEE consortium, but it designed it in a way that no one understood. So now, if you think about, say, computer chip design, we design computer chips the way that we always have. We just iterate on those designs to make them faster and improve them. Now, the second example is Google have been toying with an artificial intelligence called Alpha Evolve that evolves its own programming and code. Some of the recent outputs of Alpha Evolve are beyond human expertise. Okay, so now we start combining these two things together. When we think about software development, at the moment, human software developers follow very distinct and strict rules on how they develop the software, the structure of it, etc., etc. What happens when artificial intelligence reaches the point in time where it's discovered a better way to write software? So a little bit like the computer chip, it discovers a better way to write software. It's iterating now at speed. At what point do human software developers start failing to understand how the software has been built? So this is one of the large threats that I see looming, because increasingly everyone is a software developer. So I don't develop software myself, but I'm starting to mess around with Replit to create software for the 311 Institute. Now, it used to cost my company sort of £250,000 to £1 million to develop some of the software that we actually use. I think I can use Replit to clone some of the software that I've produced or had produced, but do it for like $20. So if that happens, basically, then I'll put that on. It's going to be the Starburst. you'll see later. I'll put that onto the website and you can play around with it all. Now, when we think about OpenAI again, so literally, we've just talked about this. OpenAI has now unveiled what they call an agentic software engineer. So this isn't just an AI that writes code. This is an AI that does all of the documentation for you and everything else. So increasingly, one of the reasons why these large AI companies are focusing on software development is because if you think about what they actually do and the kind of people they need software developers. Software developers are in very high demand. The wages are generally very high. But in terms of demand versus supply, the supply is actually quite scarce still. So if big tech can solve the problem of automating software development, then they can rapidly accelerate their own software development roadmaps and pipelines and so on and so forth. But they can also change the game in terms of cost. Now, at the moment, OpenAI, we think, wants to sell agentic software engineer services for about $20,000. And we don't know whether that's a month or per year. When we think about some of the open source community like Llama, inevitably OpenAI wants to set the cost of an agentic software engineer up here, but it's probably going to end up down here. We also think that this, while a lot of organizations are leaning into this, and I've seen quite a lot of software development houses that are accelerating their own pipelines by 66% using AI software development, we also think that there might be an Uber problem here. Now, bear with me on this. Now, when Uber first came into the market, compared to regular taxis, their main appeal was you could call them on demand via your smartphone, and Ubers were really cheap. As Uber scaled, as Uber started eating the market, as taxis became a little bit harder to get, as basically we saw taxi drivers in New York complain about the value of their medallions and so on and so forth, as Uber became dominant in key markets, what happened? The prices went up. So a cab ride that used to cost you $3 now costs you $60. So there is a danger here that artificial intelligence over the medium to long term replaces almost all human software developers because it's cheap, it's effective, it's fast, it works 24/7, all that kind of stuff. And that over time, in 10 years' time, all of a sudden, the cost of software development isn't falling any longer, it's increasing because these companies put their prices up, because agentic software engineers become dominant. And if my agentic software engineer is the best one and you want to use it, you're going to pay for that. So yes, agentic software developers are pivotal at the moment to helping organizations around the world accelerate the delivery of their software development roadmaps and features and so on and so forth. But you've got to be really careful that as a company, you don't get rid of all of your human software developers, because I reckon price inflation is going to be coming in. But we're going to have this dip and then it's going to go up. So check in with me in 2035. Now, Satya Nadella recently went on stage, so this is an official announcement. Excuse me. He says that AI is already generating 30% of Microsoft's new code, which then leads credence to Kevin Scott, the Microsoft CEO that I just talked about, saying that by 2030 they think it'll write 95% of Microsoft's code. Now, when we actually think about this in the context of the other big tech giants, we saw Google. So Google also have gone on stage and said that AI has written 30% of their code as well. We saw Amazon's artificial intelligences save 4,500 man years of software development time and $256 million worth of cost because AI updated 30,000 legacy Java apps. So if you are a software developer, the writing is actually on the wall, literally on the wall here. So next, Um, OpenAI has released ostensibly ChatGPT 4.5. Now, one of the most interesting things that I've sort of been tracking from an AI perspective over the past really sort of 3 years, I've been tracking it 10 years, but it's been sort of accelerating more over the 3 years, is I've seen more and more companies in the space that are starting to try to teach their AIs about human behaviors, human relationships, and help them become more social. So increasingly, I mean, I've called these over the years social artificial intelligences. They're AIs that don't just listen to you and then spit stuff out ad verbatim. They're AIs that listen to you, they listen to your tone, they try to figure out your emotions. Um, they try to end up being much more of a personal assistant. So increasingly, we are starting to see AIs that are specifically trained to have an EQ. Now, we've seen some AIs like the large foundational models basically that have been trained to have an IQ. So Google Gemini basically has an IQ of about 136. ChatGPT has a verbal IQ of 155, putting it in the top 0.1% of humans. But while we've sort of always said over the long term that AI will never have the same emotional quotient, EQ, as humans, it's getting really good at mimicking it. AI will never have true emotions, but yeah, a digital human, basically with a digital face, backed up by a neural network brain, you know, it'll convince you that it's sad, etc. So anyway, so expect AI to have more IQ and more EQ. And then the next one, obviously, futures quotient and all that kind of stuff. Lots of Qs to go around. So now, when we have a look at Nvidia, so Nvidia have just released their new Blackwell Ultra chips. So these are the GPUs basically that come after the Blackwell B200, which at the moment is on an export ban for China. So China can import H100s, and we're actually seeing Huawei uh, essentially with the A910C GPUs starting to not match quite, but starting to come level with Nvidia in terms of just the power of these chips. So they've also unveiled Vera Rubin as well. So you can read more about that by clicking on that. Now, when we think about this one, so recently we've seen researchers, so there's a lot of talk about artificial intelligences we just have using huge amounts of energy. So we can't keep rolling out nuclear power stations for every data center that we are planning around the world. It's just not feasible, let's face it, let alone just the sunk costs associated with the GPUs, the memory, the hardware infrastructure, the server infrastructure, the facilities and buildings and everything else. So in this one, um, a couple of AI researchers over at ETH Zurich have managed to reduce the energy consumption that AI is using by 95%. And the way that they've actually done that is they've actually changed the AIs from using whole numbers, so decimals, to using integers. So it's a slightly technical thing. If you want to read more about it, again, click that. But when we actually have a look at different ways that we're trying to reduce the energy consumption of artificial intelligences, we've seen new computer chips, basically, that are 20% more energy efficient than what we have on the market today. We have Nvidia that is increasingly trying to get optical connections within GPUs to work. So traditional connections within the GPU are copper-based. However, if you switch out a copper-based connection within a GPU for an optical-based connection within a GPU, you reduce the energy consumption by about 75%. We've seen the University of Oxford developing new algorithms, and we've also seen a concept called reversible computing, which I've talked about before, which looks like it should be able to reduce AI inference AI energy consumption by 4,000-fold. So there are some things that we're actually trying to do to dramatically reduce both the amount of compute network and resources that we actually need to train artificial intelligences and run them. But then also there's a lot of tweaking with the algorithms basically to try to dramatically reduce the energy consumption of these mini monstrosities. However, when we have a look at all of the long-term plans for AI factories, when we have a look at Nvidia forecasts, when we have a look at buying patterns and investor patterns, we do have things like neuromorphic computers coming through, which Sam Altman's been investing in. They kind of have very, very low power consumption as well. But the fact is, overall, we are just on this massive energy and resource trajectory that is absolutely unsustainable from a planetary perspective, let alone a capital perspective. When we have a look at some of the latest AI models like GPT-5, it's estimated that they're costing over $1 billion to train because, for example, in GPT-5, each training run takes up to about 6 months to perform and is costing at least $500 million per training run. And GPT-5 has had 2 training runs so far. And then when we think about agents, so of course, obviously we move from narrow artificial intelligence to generative artificial intelligence to agentic artificial intelligence, where agents basically are the equivalent of small AI bots, small AI programs basically that are able to understand an instruction and then they do something, a little bit like the gig economy. I want you to design me a website. Well, I understand what you want me to do, so I've created it. So agentic artificial intelligence, on the one hand, we've been able to show that 1,000 AI agents are able to collaborate with one another, especially with the large language models, the big sort of 2 trillion parameter models and above. But of course, organizations like Workday, ServiceNow, Salesforce, and so on and so forth are all now developing their own agentic AI platforms. So on these platforms, the idea is that firstly, you can create your own AI agents, which can automate whatever tasks you want them to automate, and then they can collaborate together to automate and perform more complex, sort of broad-based tasks. But these same platforms are also encouraging users to actually keep the agents on the platform, as well as bring third-party agents onto the platforms, because that's how you manage them. And as I've discussed before with a lot of my cybersecurity keynotes, one of the big problems that we see with agentic workflows is you don't necessarily, unless you have a way to authenticate your agents and you've got a way to manage and observe them, then you don't know where those agents are. You don't know who created those agents. You don't know if those agents are running on North Korean infrastructure. You don't know if they've been compromised. You don't know if they're safe, secure, resilient, and all the things we care about. So increasingly as well, I've seen a couple of organizations like Okta that have been talking about giving individual AI agents their own human-like, employee-like identity. So when you go to the office, you have to scan your Matt card and it goes, yes, you are Matt. I'm going to let you into the BCG building in London. Increasingly, sort of a lot of the identity and verification companies like Okta and Verint and so on and so forth are now trying to create IDs for these agents. So one of the big sort of opportunities that we have with agents is the limitless digital workforce, as CEO of Salesforce Mark Benioff describes it, because these agents will be able to collaborate with one another to do all kinds of different things. But the other challenge is we need to be able to manage and control them and secure them, and we also need to be able to kill them off, retire them, and all those kinds of things as well. So that's what these new AI sort of controlled tower platforms are all about. And that is it from me. So we've had 12 rather exciting pieces of news there. All of them changed the world in one way or another. They changed the future of careers in one way or another. And if you want to know more basically about the future of technology, basically then we've got all sorts of different things. So I saved the sales pitch to last. You can tune out now. This is the Exponential Technology Codex. It's about 400 pages long. It's got every single emerging technology in there that we've discussed. So everything in there is sort of presented in a very, very easy to digest style. So you can see that there. So I put a huge amount of effort basically into providing you guys basically with free content, literally free content. You can go to www.311institute.com and you can download that codex for free. Then we've got this. This is the Trends Codex, because it's all very well talking about technologies, but what are the trends? So again, there's about 450 pages in here. There are Foresight programs in here if you're employed in a company and you want to run some Foresight programs. But again, when we actually have a look at, some of the trends that we're seeing, again, single page, these are designed to be very, very easy to use. And then if you want to build your own exponential companies, there's an innovation codex here. This is sort of used by Huawei and Samsung for a variety of reasons. And there are hundreds of pages of resources. You get sort of little task summaries here. So it's the A to Z. I mean, every page is different. So how to develop and transfer products. So if you are an individual and you want to create your own business from scratch, or you're an organization that wants to understand how you transform so that you aren't smacked around the head by some of these things that we've actually talked about. I've got a couple of companies I've been highlighting agentic software engineering to recently. They've changed how they hire, how they invest. They've changed how they think about their entire product roadmap, sort of timelines and all that kind of stuff. The things that I've discussed with you guys just in this, whatever this is going to be, probably a 30-minute to 40-minute video, there are some very, very serious opportunities, but there are also some very serious consequences if you aren't paying attention to these different trends. So if you want to understand more about the impacts, et cetera, et cetera, et cetera, what you as an organization or individual can actually do in the face of all of this change, then obviously the sales pitch is ping me. And that's it for me today. So I hope you enjoyed all of that. I'm going to have a couple more coming, and I will speak to you soon. Take care. All the best. Goodbye.